So, hello everyone and welcome to Electronic Technocrat, your own techie guy. So, today's video will be talking about classification of sensors. Classification of sensors is that part of studying sensors where you have to know how the sensors are classified. Without knowing them, you won't understand the sensors type or the sensors used in the future studies. It is very important to know how sensors are classified. These two parts, that is this part, is first part of the second part. The second part will also consist of classification of sensors, but the second category. Alright, so we are splitting the categories into the first part and second part to make you understand even better by taking some real life examples. So, without wasting any time, let's begin. But before that, show me the intro please. Now as you have seen the intro, let's move on. You can see three boxes here. Alright, so let's fill them. The first one is classification of sensors. Well, classification of sensors. According to me, classification of sensors can be the simplest classification to the very complex classifications. Alright, I'm not gonna take the complex classifications nor very simple classifications. I'm gonna take the intermediate one, that is important classifications that are needed for you to understand the concept of sensors. Alright, so I have segregated these classification of sensors into two categories. The first category would be analog, active and passive sensors, my bad, and the next one is analog and digital sensors. Alright, so let's get to the first category. The classification of sensors, that is part number 1 out of 2. We have got two parts, so this is part number 1. There are too many classifications, ranging from the simple ones to the complex ones, and just like Ryan Reynolds is confused here, I guess we have to go one at a time. Isn't it, Ryan? Don't worry, you're looking so worried. Don't worry, we'll go one by one. Alright, so we're talking about active and passive sensors. Alright, so the first thing we are going to go out. Oh, wait a minute. We've got a question. If the sun disappeared, which type of sensor would miss it the most? Would it be a passive one or active sensor? Well, I think I'm gonna have to think on this topic. Which sensor would miss it the most? Alright, my condition is just like this smiley or the emoji right now. But I'm gonna give you the answer in the last part of the video. Don't worry about it. Alright. So let's move on to the definition of the active and passive sensors. The active sensor is a sensing device that requires an external source of power to operate. That's very logical. It doesn't have its internal source of power. It has to take the power from an external source, that is a battery or a solar cell or a solar battery or anything. A passive sensor is a device that detects and responds to some type of the input from the physical environment. So whatever input is given in the form of physical environmental factor, remember the word physical environmental factor is given as an input to this passive sensor. It will detect that and it will respond to the same. Alright, isn't it? Very simple. So let's move on. Now we are getting to the principle of how these sensors are actually gonna work. Alright, before turning to the examples, we're gonna see the principles. The first sensor we're going to talk about is active sensors. Cameras are active sensors with flash turned on. Justify this statement. Well, let's start the justification. We'll draw a diagram first. Let it be a Nikon or a DSLR, Sony DSLR or any kind of a camera here. We have an object in front of us. Let it be a tree or a scenery or anything. Alright, for now, let it be a tree. Alright, I'm going to take a picture of a tree with the flash turned on. Alright, when you take the picture with the flash turned on, the camera sends its own source of light. As you can see, its own source of light. This will hit the object here. Okay, this will hit the object here. This will hit the object here, sorry. This will hit the object here and it will illuminate this object. Alright, it will illuminate this object, and the camera captures the reflected light back to the camera lens. This is the camera lens. So whatever light is reflected from by hitting or after hitting this object, some part of light is reflected back, isn't it? So that light is being captured by the camera lens. As simple as that. The cameras are active sensors with flash turned on. This is the main reason behind it. Alright, so the cameras are active sensors when the photographer uses the flash. It illuminates the target, and measures the reflected energy back to the camera. This is the reflected energy back to the camera lens. Alright, so this is a very, very simple principle on how the active sensors work. Yeah, let's take a cup of coffee. We can relax a bit. Now, we go to the second part, that is the principle behind passive sensors, or the working behind the passive sensors. Cameras are passive sensors with flash turned off. Please justify this statement. Alright, I'm going to justify this statement for you. You can see the diagram here. Now, as you can see, the light source is not the flash anymore. This is the exact same situation, but the light source is not the flash anymore. As you can see, the light source in this picture would be the sun. Alright, so this is the external light source. As I have discussed earlier, passive sensors take the input as a physical environmental factor. Alright, it's shown here clearly. This is a physical environmental factor. Alright, sun is a physical source of light. Alright, so it is illuminating the object here, and the light is reflected back to the camera lens. The rest procedure is exactly the same. Only thing is the flash isn't working here. The flash is completely turned off, whereas we are using the external source of light, that is the sun, or we can say the physical source of light, that is sun. Alright, the rest principle remains the same. It's going to reflect back and the camera lens is going to capture it. Okay, so the principle is very clear. Yeah, that's very clear. So let's move on to the examples of these sensors. Yeah, correct. Let's move on to the example of the sensors. Alright, example number one. The example number one is very simple. This is a very, very daily life basis example. We've seen two images here. We are going to see two images here, as you can see right now here. We will talk about this image first. Alright. In this image, you can see a normal landscape here. Buildings, roads, and some different landscapes. And a sun and a satellite sensor, and these arrows are very important. Now let's focus on these arrows. First, what happens is the sun is emitting the light. Here we go. The sun is emitting the light, and the light is hitting the Earth's surface. After hitting the Earth's surface, after passing through the atmospheric window. The atmospheric window is nothing but the atmosphere through which it is piercing through, and it's hitting the Earth's surface. Alright, atmosphere is our atmosphere. Alright, so after the sun is emitting the light and it's piercing the atmospheric window and hitting the road, or we can say the Earth's surface, it is getting reflected back to the satellite's sensor. Alright, this is the first example. Alright, the sun is emitting the light, it is hitting the Earth's surface, and it is reflected back. The light is reflected back to the satellite sensor. Now let's go on to the second picture. Second picture looks similar but different kind of arrows, and also a different concept. The active sensors, whereas the active sensors illuminate the target. Alright, the active sensors are illuminating the target. In this example, first of all, you can see this arrow which is going downwards from the satellite sensors. That's correct. It's not coming from the sun, it's coming from the satellite sensor. The satellite sensor is what we can say emitting some kind of light waves. It is hitting the Earth's surface, bouncing back through the buildings, and going back to the satellite again. This is the example of the active sensors, and the first example is the passive sensor. Alright, why is this an example of passive sensor? Very logical, because it is taking help of the physical environmental factor or the physical light source, that is sun. Whereas here, as you can see, this is an active sensor example. Active sensor, what it's doing is the satellite sensor is sending the light waves. It's hitting the Earth's surface, it's bouncing off the buildings here, and again it's going back to the satellite sensor again. Alright, This is the first example. Yes, and this example is called as double bounce back scatter, because as you can see, this is double bouncing here. The satellite is throwing the light waves and is getting those light waves again after reflecting back. This is called as, or the phenomenon is called as, double bounce back scatter. Alright, so let's go on to the example number 2. This example will be active sensor remote sensing image example. Alright, remote sensing. Alright, so in this we will be learning specular reflection, diffuse backscatter and double bounce. As you can see, there is an image here. Okay, this image is called as synthetic aperture radar image. A long name, isn't it? Don't worry about it. Just take it as a simple radar image, okay, of a place basically. For an untrained eye, it's just a bunch of black and white pixels. As you can see some white pixels, some black pixels. That's it. That's all we can see. But the reality is, there is more that our untrained eye cannot see. For example, there are 3 phenomena, like the specular reflection, the diffuse backscatter, and the double bounce. The specular reflection is where the dark spots are in the image. Exactly. This is the dark spots. Or we can say the specular reflection is where the black pixels are. Alright, in our case, this is a east-west flowing river. Alright, the river is an example of specular reflection in our image. Alright, now then second one is the double bounce. The bright white in the center is the double bounce backscatter. Here you can see there's a bright spot here. This is called as double bounce. In our image, it is an urban feature like a building, or it is not basically entirely clear in this scale. It can be a building, it can be anything. But here, this bright spot is a double bounce. Now the third term is diffuse backscatter. Finally, the majority of the radar image is rough surface and diffuse scattering. This may be from the growing vegetations in the agriculture areas. That's absolutely correct. The remaining areas is called a diffuse backscatter. This may be the agriculture areas basically, because we have included the river, we have included the main buildings, so whatever left is agricultural part, so that comes under the diffuse backscatter. Alright, so it's a very simple example of active remote sensing image example. The next one is passive remote sensing example. We are going to see 2 images here. The first one is true colors and the next one is multispectral image. Absolutely. This is Rocky Mountains, and this Rocky Mountains is taken from a radar system or a satellite view. The first one is a true color. This next one is the multispectral image. The power of passive remote sensing is to see light in the whole electromagnetic spectrum. For example, the multispectral image can have different band combinations like the color infrared. As you can see, this is a true color. So as you can see, the green part is a vegetation part, the blue part is a river, and again the green part is the vegetation part. So it's very easy to define those terms. But when it comes to multispectral image, it is really important to realize how it emphasizes the healthy vegetation in the bright red area. For our case, it's a pink area basically, because the color is scattered. This is a pink area, to say the least. There's a lot of things to learn in this scene. The bright white is built up areas. The darkest shade in the water is the water basically. The bright white is a lit up areas. Alright, the darkest shade is the water. In the east, this could be a transmission line right way, because how it's consistently in the same way. This could be a transmission line basically, because it is completely, or we can say constantly, the same width. Alright, finally you can see that we have 2 images. One is a true colors images where we can see exactly how the mountains look from the satellite view, and the another one is multispectral image. The healthy vegetation is the bright red part, alright, to say the least, and the bright white part, or you can say here, this is the bright light parts, or we can say the bright white parts basically are the built up areas, and the darkest shade, as you can see here, the dark blue shade, is the water. And this may be a transmission line because it has the same width, so it is very easy to understand. This is a Rocky Mountain image that is in different spectral forms. Alright, This is the most amazing thing I've ever seen. Yeah, Harvey Mandel, this is very amazing thing because this is a very easy example to understand the passive remote sensing. Alright, what is the difference between both? This is a very common question that is asked. So let's start. The first one is active sensor, the next one is passive sensor. The first point is it generates electric current or voltage directly in response to the environmental simulation. Very easy to understand. The next one is it usually requires additional electrical energy for excitation. That's absolutely correct, as we have seen in the previous examples as well. The active sensors provides their own source of illumination, whereas the passive sensors can only be used to detect the energy when naturally occurring energy is available. Very simple again. The third is they are able to contain, or we can say obtain, measurements anytime. It doesn't matter if it's a daytime, it's a nighttime, it doesn't matter at all. But the passive sensors had got a limitation. It can obtain measurements only in the daytime. It's restricted in the daytime itself. We cannot have the measurements in the nighttime. Alright? So this is a very simple difference between these both sensors. And finally, the answer to that question, alright, would be passive sensors. That's correct. The answer to that question is passive sensors. Now why? Because passive sensors use the reflected energy from the sun, and it needs the sun to work because it needs the sun constantly to work for it. Whereas the active sensors generate their own source of illumination. Alright, so it doesn't need any kind of illumination source, external illumination source. Alright, so our winner is passive sensors. The answer to this question is very easy. Now I'm going to repeat it again. Passive sensors are using the reflected energy from the sun, and it needs the sun constantly, and if the sun disappears, the passive sensors are of no use at all, as you have seen in the example of the satellite and the sun. Okay, but the active sensors generate their own source of illumination, so we don't need any external power source like the sun itself. So tada, we have a winner, that is passive sensors. Simple, ain't it? Alright, so the next part we will continue with the part number 2 of this classifications of sensors topic. Till then, take care, goodbye, and stay home, stay safe. Thank you, and stay home, stay safe. Hey you! Yes you! If you like our video, just hit the subscribe button and also hit the bell icon to stay notified for the future updates. Hey you! Yes you! If you like our video, just hit the subscribe button and also hit the bell icon to stay notified for the future updates.